Hi everyone. So today we are going to talk about SQL Server functions. I hope everyone got some time to go through the previous recording and also do some practice using the assignments and also using the book that I had provided after the last class. Let's talk about functions. A function is a piece of code or routine that accepts parameter and is stored as an object in SQL Server. The function always returns a result or result set from invocation. A function can be called within a select statement or even in a where clause, right? So one of the most important property about the function is that a function would always return a result set, right? So basically, uh, normally there are so many objects on SQL Server, right? We have a store procedure, we have functions, we have triggers, etc. We have views, we have tables. So in which scenario we should be using which object? So if we want to understand that, then it's important for us to understand what is the definition of each one of them. Because from the definition, you can get the idea is that in this instance, I should be using what. So one of the important property of functions is that they always return a result set, right? So if there's some condition where you want to return a result set, right? So in that case, you should be using function. And the other good property about the function is that you can use the functions inside the select statement, right? So we'll learn about the store procedure later, and then we'll compare store procedures to function. But as of now, understand that you can't use store procedure inside the select statement, but you can use the functions. Also, there's no rules defined that store procedure would always return a value, but with function you'll always get a value. So let's understand what is all of that, and let's go more into what are the different of functions, etc. So SQL Server supports several type of functions. The first one is the built-in function. We have already used some of the built-in function during our previous classes, right? If you remember, we have used man, mix, or max, min, sum, average. All of these are the built-in functions. Then we have the scalar function. Scalar function is a function which returns just a single value. So any function, if it is returning a single value, that is a scalar function. Then comes the table valued function. Any function which is returning more than one rows or more than one column, that is a table valued function because it is returning something in the form of table. When we talk about the table valued function, there are two types of table valued function. One is the inline table valued function, and second is the multi-statement table valued function. We'll talk about both of them to understand what are the differences, in which situation we should be using inline, in which situation you should be using multi-statement. Next comes the CLR functions. CLR functions, we don't use it from the database side, but whenever you are using the .NET code, etc., any language code, from there you create the functions. Those functions are known as the CLR functions. Let's talk about the built-in functions now. A lot of functions are provided already by Microsoft, right? So if you execute any function which is already created, that function is actually a built-in function because that its definition is already defined. For example, if I want to get the current date and time of my SQL Server system, I can use select get date. Now get date is a function. How do I know it is a function? Whenever we have a function, it always would have a parenthesis. So this is how know that I'm calling a function. Function will always end with a parenthesis, right? Like this, the bracket. So I am going to execute this select get date, and since this is a scalar function, so that's why I am using select and then the function name. And this will give me the value of the current date and time. So if I execute this, you can see that I am getting the current date and time of my SQL Server, right? So this is a built-in function. So similarly, we have lots of built-in functions of different types. So if we talk about that, these are the some of the other built-in functions which are there, right? Again, for example, if you want to count the records of a in a table, if you want to do the average, if you want to do the minimum, or if you want to do the sum, all of that functions are already created in SQL Server. You don't need to create that separately. For example, let's go and let's talk about the count star. So I'll go to AdventureWorks 2019. Here I will write select count star from human resources.employee. If I do that, I'll get the total number of count of in this table, right? So this count star, that is a function, which is a scalar function, and it's a built-in function, right? Because any function is a scalar function if it is returning one single value. Is someone non or mute? I'm getting some. Okay. There are some other functions as well, which gives us information about the server and database configuration. Those functions are also the built-in functions. So we are just talking about what are the different built-in functions. There is no limit on the number of built-in functions that we have, and also you don't need to remember them all. So definitely, with time, you'll be able to understand a lot of built-in function. But again, you don't need to remember all these built-in function. You can just try to, for example, you have a situation where you want to do the sum of the values of some column, right? So definitely, then in that case, you can just search for such functions. You don't need to remember that what function is there used for this particular thing. And even if you are not able to remember, you are not able to recall, what you can do is that you can create that function for your consumption. For example, the sum function, that is very simple. If we don't want to use what SQL Server has provided, what Microsoft has provided, I can create my own function as well. And those functions are the user defined functions, right? So similarly, we have some mathematical built-in functions as well, like absolute, uh, uh, power, random, scaling, floor, sine, square, log. So all these are the built-in scalar functions or built-in mathematical functions that we can use to do our queries. But again, you don't need to remember all of that. This is just for your reference that we have functions of each of these types. And if you want, you can use this in your queries based upon requirement, or you can create them on your own. We'll talk about creating some of the built-in functions as well, for example, sum, etc. Then SQL Server has a special type of functions as well, which are known as the ranking function or the windows function, right? So ranking functions are non-deterministic functions that return a ranking value for each row in a partition. Ranking functions are new with SQL Server 2005 and allow you to rank or a row number within a result set. So we'll have a separate session about these ranking functions because they are very important concept. A lot of questions or a lot of solutions that we write, they are dependent on these ranking functions. So using ranking function, you can actually determine uh, the the ranking of a particular data within a partition. Okay, so we'll talk about that in a whole session. I'll take a separate session on this ranking function. So as of now, we can just understand that there is a thing called ranking function also, which is which are the built-in function through which we do something in SQL Server. Then let's talk about the user-defined function. When we talk about the user-defined function, we have the major category of three different function types, or you can see it two as well, right? So if we have to divide the type of functions that we have, the first type of function is the scalar function. A scalar function is anything which is returning just a single value. Then comes the table valued function. A table valued function can be of two types, right? One is the multi-statement table valued function, second is the inline table valued function. When we talk about the multi-statement table valued function, it is a combination of the view and store procedure. Then comes the inline table value function, which actually returns a table and is referenced from the from clause, just like a view. So as I was saying that there are two types of table value function. We have one is the multi-statement. So as the name suggests, this multi-statement table value function means basically in the function body you will have multiple statements. So any function where in the function body we have multiple statements, that is known as a multi-statement table value function. Then other thing is that the return type here. So that has to return data in the form of the table. Next comes the inline table word function. So basically in the inline table word function, there's always a single select statement in the body of the function. You won't find more than that. So any table value function which has just single statement in the body of the function, then that would be known as the inline table function. I'll show you the definition of everything. Will do examples on everything. So don't worry even if you are not able to get it right now. So CLR functions are basically which are used in the .NET code. You don't need to worry about the CLR functions and all. Just understand that these are a special type of functions which are used by the .NET, like anyone who is working on C# and all, right? So they use CLR function to connect and do something in the database. And before you can use the CLR function, this needs to be first uh, uh, enabled in the SQL Server, because by default CLR functions are not enabled because there are some security related constraints as well, but we don't need to go into detail of that. Next comes some non-deterministic built-in functions. So I hope that you guys understand the definition between deterministic and non-deterministic. So as of now, when we were talking about the scalar function, we were talking about the deterministic scalar function. That means, for example, you are doing the sum of all values in a column, right? So in that case, that sum function is a deterministic function. Why? Because the value of sum would always be same. Even if you execute that 100 times, you'll get the sum same. Um, the only way the sum would be different if something changes. So if something doesn't change in terms of values and all, then the sum would always be constant, right? So when the values that we are getting as the result of a function is not changing, right? It's the same every time and we are able to determine the value, then that such function is known as the deterministic function. While if the value of some function changes every time we execute it and it's hard to predict that what would be the next value or what is be the next time when we execute it, what is the value that we'll get, such functions are known as non-deterministic functions. For example, I'll show you an example of the new ID function. So suppose that I just use select new ID. If I execute it, you can see when I executed the first time I got this value. This is actually known as GUID value, globally unique identifier. So this is the result set that I got when I executed first time. Let me execute it again. Next time when I executed it, you can see that I got this value now. This is again different. Is there any pattern you can find out? Again, this is different the third time when I executed, right? So any functions whose value or the result set is not predictable, that is known as the non-deterministic function. I hope this is clear to everyone. Next is a term known as schema binding that I want you to understand. So basically, this is actually valid for views as well. This is schema binding thing. Anyone wants to ask any question? So schema binding connects the function to the object that it references. All views and user-defined functions referred by the function must be schema-bound as well. All objects referenced by the function must be in the same database. Basically, there's a thing called with schema binding option that we use to create a view or the function. What will happen with when we'll create any function or views with the with schema binding option? Basically, you will not able to change the definition of the underlying objects that are there in that view or function. What does it mean? For example, you have created a function on the employee table, right? You have an employee table on which you have created a function, and this function you have created with the with schema binding option. What will happen in that scenario is that uh, if you want to add any extra columns in this employee table, and you have that function there with the with schema binding option, SQL Server will not allow you to change that, because when you are giving with the schema binding, SQL Server is understanding that the schema of this object is froze now, right? So you can't make any changes to the schema of the object. So this is what means by schema binding. In order to make any changes in the employee table now, what you'll have to do is that you'll have to drop this function that you have created, and after that only you can make changes to the employee table, and again you can create the function after that. So this is what the with schema binding option. And I'll also tell you when just when we'll revise this function and views that what is the uses of this with schema binding option in a function. So if we summarize what we have learned so far, and after that we'll move on to the actual queries where we'll run different type of functions and we'll see the differences. But before that, what we have learned so far is that there are three types of functions overall. One is the scalar function, which will return just a single value. Then we have the table valued function, in which we have multi-statement table valued function and the inline table valued function. Also, what we have learned is that built-in functions perform common tasks. They have been developed over the years and their numbers keeps increasing as new SQL Server, new situations warrant the inclusion of new solutions in SQL Server. You can create your own function. Basically, there's no limit on the number of built-in functions that we have in SQL Server. And even with each version of SQL Server that Microsoft is releasing, the number of built-in function is again rising, right? So you don't need to remember all of that. What you need to remember is that what you want what you want to do as a particular task, and then you need to see if you know any built-in function which can be used in this particular instance. If you don't know, that is also fine. You can create that built-in function by yourself, which would be by a user-defined function. So for example, if I have to just explain you a scalar function, if I have to show you, this is an example of the how we define the scalar function. So we write create function, then name of the function, then in the bracket start. Here we give the input parameter. Now here, if you see, there are two different parameters that we are using, right? So there is no limit on the number of parameters that you have to use. There is also, this is optional. So if you want, you can define a function without a parameter. But this input parameter is something that if you think that if you need to define, right? For example, when we were using the getDate function, right? So for the getDate function, definitely we didn't need to define any parameter because we don't need to pass anything to get the current date and time. But so for some of the function, for example, the sum function, right? Here we have defined a sum function. So if in order to get the sum, right, you need to provide the numbers for which you want to do the sum, right? So for example, for which numbers you want to do the sum, whether it's like a, b, and all. So then if you provide two numbers like 1 and 3, then you'll get the sum as 4, right? So if that is something you want, definitely you need to give the parameter. So as I said that the input parameters, these are optional, but if your situation ask you to define the input parameters, then accordingly you have to define the parameters. Now there is no limit on the parameters. You can either define 1, 2, 100, 200, things like that. So that will totally depend upon the business requirement. For example, if I have to do the sum, I need at least two values. We can't do sum of one value, right? So that's why here in this particular function, I have defined two different parameters. One is the val1 and second is the val. When we define the scalar function, then after definition, like after this thing, create function, function name, and then the brackets, we have to tell SQL Server is that what type of values this function is going to return. So after that, we have the returns statement, which is common. So we'll have to write it like that. After that, if you see, we have the int thing here. So int is the data type which should be returned by this function. So this particular function is going to return an integer data type. So that's why I have mentioned int here. After that, we have the while loop. So what I'm also trying to do, I'm not writing a straightforward function. Otherwise, I can just comment it this while loop, and what you will see is that this particular function is will actually return the sum of val1 and val2. It will execute it. But here, what I want to do is that I want to also make a twist in this thing. So that's why I have introduced while loop. Though we have not yet learned about while loop. That is fine. We'll learn about while loop soon. But as of now, I'll just explain you how while loop works in short, right? So this, what will happen is that first of all, the return type we have defined as integer. After that, we have the as statement, and then we have the begin statement, and every begin statement is followed by the end statement. So in every begin for every begin statement, there has to be an end statement, right? So what it does is that it binds this begin and binds actually multiple lines of code into one line. That's what it does. Now, if here after the begin we have the while loop, right? So in the while loop, what we are saying is that if the value of val1 is less than 100, so while the value of val1 is less than 100, what we have to do is that we have to set the value of val1 equal to val1 plus 1. So once the value of the val1 would be equal to 100 or greater than 100, then only this while loop will not run. And then the SQL server will come to here and it will return the value 1 plus value 2 sum. That is what it will do. So I'll just create this function first, right? So you can see that when I created the function, this po is optional, right? If you want to drop a function, how you can do that? You can write the drop function and then name of the function. So here, this is the name of the function. So I can just select this statement, I can drop the function. So now I have dropped the function. Now if I want to again create it, I can create it here. Now if you have multiple schemas and you want to create some function in specific schema, right? You have to give the schema name. For example, I want to create it in DBO, so I can write DBO.function name. If I want to create in some other XYZ schema, I can give like XYZ dot this. So this is the other thing I wanted to mention. Other than that, let's create this function first, and then I'll execute it with different values of val1 because that is what is would change the result set. So for example, if I have to execute it, I'll write select dbo.fx this. Then I need to give the values of the val1 and val2. For example, I keep the values of val1 equal to 2 and val2 equal to 5. I'll take another example as well here where I'll do val1 equal to 102, val2 equal to 40, right? So this is the definition of the function, right? I have kept the definition as well here. Let's talk about the first execution. What will happen if I'll execute this one, this particular one? We got the value as 105. Who got surprised here that why we are getting the sum as 105? Why it's not coming like 2 plus 5 equal to 7? That is what the sum should be. But here in this case, we are getting 105. If I'll execute the second one and intentionally I have kept it like that, so I'll get it 142. So which you think is correct only because 102 plus 40 equal to 152. Anyone wants to tell me why this 2 plus 5 is coming as 105 while 102 plus 40 is coming as 142? Anyone who got the point here and can explain me why it happened like that? Okay, because this is the first time we are covering this, so I'll explain you guys. So what is the value of the val1 in the first one? It's 2, right? So the val1 value is 2. The value of val2 equal to 5. So SQL Server, first of all, it will come inside the body and it will check while val1 is less than 100. So 2 is less than 100, which is true. So when it goes true, then it will come inside the body of the while loop. So here we have the body of the while loop. In the body, we are setting, so through set, we set the values of anything. So here we are setting val1 equal to val1 plus 1. That means it would become 3. 2 plus 1 equal to 3. So again, while loop will keep on executing again until it becomes false. That's how the while loop works. So it became 3. 3 is less than 100, which again is true. So it will come here, it will become it to 4. Similarly, it will go on till 99. So 99 is less than 100, which is true. So it will again set the value to 99 plus 1, which is 100. Again, it will come 100 less than 100. Now this becomes false, right? Because 100 is not less than 100. So it will go and it will go to the return part of it. And what is the current value of val1 now? It's 100 because it came out of the control only when the val1 become 100. So 100 is the value of val1 now. Plus what we are doing val2. What is the value of val2? It's 5. So that's why we have 100 plus 5 equal to 105, which is the result set of the first one. Now if we talk about the second one, what we have as the val1? 102. So 102 is the value of val1. For the val2, it's 40. SQL Server will first of all execute from here. So it will compare while 102 is less than 100, which is false. 102 is greater than 100, right? So it will, if it is false, it will never go to the body of the while loop. It will just go to this return statement, which is after the body of the while loop. And here it will return 102 plus 40, 142, and that's why we have 142. I hope this makes sense to everyone. If you want to actually create a function just to do a normal sum, you can just create it like that. You can remove this while loop. This is totally optional. This is just I wanted to explain you this with a twist, and that's why I did it. So I can just write it like this, and I can give it this name. So now if I'll create this function would get created. Now you'll get a simple result, which is the expected result out of this. So I can write it like this. If I see the result set of this execution, the first one is giving you 7 because 2 plus 5 is always 7, while the second one is giving you 142 because 102 plus 40 equal to 142. Similarly, if you want to create a, a function which would give you the difference between two values, then you can just create the function accordingly. Here you'll change the name as per what you want. And then here you can change like return val1 minus val2, something like that. So in this way, you can create your own functions. Now let's talk about some other type of functions as well. So we have the inline function and the multi-statement table function. Let's try to understand what is the difference. So here, okay, let me do one thing. Let me create my own function because again, if I'll go, I'll have to here this function will not make more sense to you. So let me check what tables we have in Bash 266 database first. So we have all these tables. So what I'll do, I'll quickly create both inline function, right, and the multi-statement LVL function of my own right now. And then through that functions, we'll just try to understand the differences. So create function, then dbu dot get customer details. And then in the customer, what are the columns we have? Customer ID, customer ID, int, returns table as return. Select star from dbu.customer where customer ID equal to and the rate customer ID. So this is one function. Here I can create another one as well, which would be the multi-statement table function. So create function dbu dot get customer details history. Here again I want to pass on the customer ID and then after that I need to return specifically I need to mention what all things I want to return. So returns let me see what do we have in the customer history. Okay. So I'll return customer name, varchar 50. Then I'll return gender maybe char 10. I'll return the customer ID. Okay, so this is how I want to return the value from the multi-string. As then here I need to mention the begin and the end. Before the end, we should have the return statement. And now here is where I'll write the logic of what I want to do, right? So what I want to do is that I want to declare first of all a variable, uh, or let me do one thing. I'll write insert into this customer table. Okay. And then what are the columns I want to insert? Customer name, gender, and then customer ID. Select customer name, select. So now what I'm doing here is that the first function that I've created, let me first create this both functions. So this is the first function, which is the inline function. The second function is the multi-statement table function, right? I can write it in different way as well, but I just wanted you to let you understand this with the help of the pattern in which I'm writing the query, right? So let's talk about the first one. What will happen with the first one is that whenever you'll give the value of the customer ID, which is of the type integer, because whenever you are defining the parameter, you have to tell SQL Server specifically about the data type of the parameter as well. So here it would be int. Then you are returning something in the form of table, right? So that is what you're doing. Now, after that, you in the you have the return statement. So that is the first statement that comes in the inline function. So whenever you will see inline function, you'll see that on top of that, if at when the body of the function is starting, it will have the return statement. So that is how you can understand whether a particular function is inline table valued function or the multi-statement table valued function. Also, there would be just one single statement in the inline table valued function. So here, after the return statement, we are using just one single select statement. So that's how it is. So whatever the customer ID it will you will pass here, the this function will give you the customer details of that customer. So it will give you all the columns. For example, if you want to execute this one, what I can write is that select star from. So basically, when you execute the table valued function, you have to write it like select star from. When you were executing the scalar function, in that case, you were just using select and then the function name. But here you have to give the select star from thing. So what I'll write here is that select star from then function name and in brackets what is the value of customer ID. So if I'll do that, I'll get all the columns from the customer table and it will have for this customer ID 1. So it will have the customer ID, name and address. These are the columns that we have in the customer table. In the same way, there is the second function, which is the multi-statement table red function. This we have already created as well. So I'll just go here and I'll write the same thing. DBO customer details history and then 1. The major differences between the inline table function and the multi-statement function is the where you are facing the results return thing. So if you see here in the multi-statement table function, we have the return coming after all the different logics that we have, right? So here you can write more codes as well after the begin, because in multi-statement function it is allowed to write multiple lines of code. So you can, if you want to do, you can write more code here, right? So once you do that, in the end of the body, whenever everything is done, you have to mention the return statement. That means now you are returning the control to the SQL Server. And also, one of the important thing is that here is that whenever you will define the inline table value function, here there you just mention returns and then after that table. But here, whatever format you want to return your table in, you have to define that. So I want to, I have created a variable of the type table here, and then the columns I have put which I want to return. So my result set would be like customer name, then gender, then customer ID. So if I run this one, this particular one, you can see that I'm getting customer name, gender, and then the customer ID. For the customer ID 1. So here I'm getting that from here. I'm inserting that into this table, and then this table is getting returned by the SQL Server. So this is how the multi-statement table value function looks like, right? Let's again see another function here. So suppose that we have this function. So this is again an example of the multi-statement valued function. Why I said that? Because you can see that we have the returns statement, and then after that we are defining the a variable of the type table. And also we have the return statement in the end. So that's why this is a multi-statement table valued function. What we are doing through this one is that for any date time that you are passing, right? You are it returning what is the year, what is the date, what is the month, and all of that, right? What is the day? So if I create this particular thing, I can just write in order to call this, I can just write select star from debut dot udf underscore parse date, and then in brackets maybe I'll put get date. Let's see if it works. You can see that when I passed on the get date, I'm getting this info from there, because what I'm doing is that I'm using the year function, which is a built-in function, month function to return the month, day function to return the day of the year, right? And then this date is coming directly from what we have given here. So get date function. So everywhere here I'm using scalar function to give you the values, right? And then finally this particular function is a multi-statement table value function. Any questions so far? Okay. So as of now, we have learned about views and function. Now I want to combine them both together, and I want to just revise this all, right? Whatever we have learned so far. So we have already learned how to create a view, right? But today we talked about a with schema binding option, right? So as I said, so as of now, what we were doing is that we were writing like create view name as then select a statement. This is what we were doing. But if we can put the with schema binding option as well, which is optional, right? So create view as with schema binding. So what will happen? Whatever the underlying tables are, what are the tables that we are using here? Sales.order, sales.order details, right? What will happen is that you won't be able to do any schema changes in this object, right? And in order to do that, what you'll have to do is that you'll have to first drop the view. Once you drop the view, then only you can make any schema related changes. So that is what. And the other thing is from the performance perspective. Whenever you define a view with the with schema binding option, or the function with the with schema binding option, SQL Server stores the result set of that view or that function in the disk, so that it can actually access that view or that function faster, right? So that is the purpose of this schema binding thing. So just to make it clear to you guys, so basically uh, whenever suppose that in which situation we would like to use a view with the schema binding option, if we have to talk about that. So basically, suppose that you have tens of millions of records or hundreds of millions of records in some particular table, right? And then you are using the joins of those tables. Suppose that you have 5 tables, you are using the joins of those tables, and this data set is very old, and there's no columns being added to these tables. These are very stable tables. So in that case, what you can do, you can use those joins inside this view with the with schema binding option, and you can just query it from the view. Whenever you'll create a view with the with schema binding option, definitely the limitations of that view would be that whatever the base tables are, you won't be able to make any changes to them. You can't drop a column, you can't add a column. But again, you can query that whole stuff in a faster way. That's what the purpose of this. So that's when we use the with schema binding option. Also, if you want to limit users to actually make any changes in some particular table, then you can create a view with the with schema binding option on that table, and that way people would not be able to drop or add any columns to that table. So that is another thing. Let's talk about some of the facts in the views, and also please pay attention to this one because in the end I'll ask some questions about this. So please make some pay some attention here. If a view is created with the view option called schema binding, then it guarantees that the underlying table structure cannot be altered without dropping the view. This is what I was talking about. The body of the view is just a select statement. You can add new columns to the view by creating new columns in the select statement by using expressions. So in order to create a new column in a view, what you can do is that you can add those columns in the select statement. You can prevent users from seeing some columns of an underlying table by removing the columns from the select statement in that defines the view. For example, you have the employee table, which has the salary column as well, right? And you want to avoid other users to see the salary of the employees, but still you want them to see the other details. What you can do is that you can remove the access from the employee table. You can create a view without that salary column, and then you can give access to that view to those users. In that case, they would be able to access only through the view, and they would not be able to see the salary details of the employee, right? So if we have some particular businesses situation where we want to hide some columns from the users, in that case I can use the view and then just give access to that view rather than giving access to the whole table. You can rename column by using column aliases just as in the select statement. So definitely, in order to change the name of the column in the view, what you can do, you can use the as keyword, or you can use the alias for the column. That way you can just give you just different name for that column. Views provide a level of abstraction between the end user and the database. Definitely, because you can change or rename the column names, you can restrict the number of columns coming from the table and all of that. So definitely view provides a level of abstraction with all these things. When a database requires complex join of tables, you can make user queries easier by embedding those joins into views. So this is also possible. So basically, when you have a lot of complex queries together, what you can do is that instead of using those complex queries every time, you can create a view with those queries and then you can use the view. That would mean the same thing. So there are two options with the view. One is the with encryption and second is the with schema binding. With schema binding, we already talked about what is with encryption here. So with encryption, suppose that you don't want the end user to see the definition of the view. Then you can create a view with the with encryption option. What will happen if you would like to see the details of the content of the view with a view which is defined as with encryption option, you just would not be able to see that. Let me do an example of this one because I have not done yet. So for example, create view. Let's suppose that the name of the view is customer, and then as here I'll give with encryption. Select customer ID, name from customer, right? Suppose that I created a view like this. Let me create it. Now, if I want to see the definition of the view, so in order to see the definition of any object, we have an inbuilt store procedure in SQL Server, which is the SP underscore help text, and after that you pass the name of the object. So if I want to see that, you can see that I'm getting the message, the text for object VW underscore customer is encrypted. If I don't create this view with the with encryption option, Suppose that I create it just like that. In that case, if I want to see the definition of the this thing, you will see that I'm able to see the definition of this, right? So that is the purpose of the with encryption option. After that, the user should not be able to see the definition of the view. If you want to hide the definition, you should use the with encryption option. If we talk about the select and union statement, by default in a view only one select statement is allowed, right? That is the restriction with the view. In a view you can use just one single select statement, but if you want to use multiple select statement, one way of that is that you can use union or union all clause inside the view, and then you can use two SQL statements, right? So that is one thing how you can write the multiple select statement inside the view. So if we talk about the names of the view, every view is a database object and its name is scoped to the database. That means you can't have the like you can't have two views with the same name. Every view has to be unique. View names must be T-SQL identifiers such as for tables, store procedures, and other server database object. So basically what we are saying that view name should be some you should follow a proper naming convention for the view, because if you see here, like when I wrote the view, I wrote it like bw underscore, so that it's easier for users to understand. If you have, suppose that right now I have just 10 objects in my SQL server, what if I have 10,000 objects, right? So in order to understand what is view, what is a function, what is store procedure, you should follow a proper naming convention. And that's why I covered that class where we just discussed about the naming convention and all in SQL Server. That gives you understanding about, or everyone's understanding about what is going on. Now, there are some restrictions on views as well. One of the restriction is that you cannot add an order by to the select statement in the view. So order by clause is not allowed in the view, right? You can't do that. You cannot pass parameters to view. So you can't pass parameter up. So if you have to actually pass parameters to view, you'd actually create a function there instead of the view. So a view is also known as the function without a parameter. A view cannot create a table whether permanent or temporary. In other words, you cannot use the select into syntax in a view. Definitely, you can't use the select into statement, that is not allowed in the view. A view can reference only permanent tables. A view cannot reference a temporary table. So we'll learn about temporary tables in future. But as of now, just understand that whatever the tables we are using right now, these all are permanent table, and a view can only reference this type of tables. Can we modify the data to the view? Definitely, we can do that. We have already done that in the previous classes, right? We used the insert statement to do the insert using the view into the table, right? So that is possible, but there's one restriction here. You can only do such insert, update, delete which is affecting only one base table, so that is allowed. You cannot modify a view column that is computed from a union all, cross join, except at or intersect. You cannot modify a view column whose values result from grouping, such as distinct group by having clause. So you can't do modification in such type of columns. If there is a simple select statement, then there you can, if your view has simple select statement without the group by clause, without the union, without the except, without the intersect, without the having clause, then only you can run this insert, update, delete statement on the view. The view columns must directly reference table columns and not be expressions or functions surrounding the column value. Accordingly, you cannot modify a view column that has an aggregate function. For example, in a view definition, it's like some aggregate functions are there. In that case, you can't modify that view. Next is the partition view. If the tables are in one database or at least one instance of SQL Server, it it is called a partition view. If the tables are spread spread across multiple SQL Server instances, the view is called a distributed partition view. So we can actually create partition view as well, right? What is a partition view? For example, I have multiple databases here, right? What if I create a view with some table from AdventureWorks 2019 and some tables of Bash 266? If I do that, that view would be known as the partition view because we are using tables from multiple databases. Sometimes we use cross instance views as well. For example, this is an instance, and then what if I have another instance and I create the view? That is known as the distributed partition view. That is also possible, right? But it won't be possible with the Azure version of view. So this is the restriction. This is only possible in this on-premise thing that we are using right now. So that's all the different facts about views. Tomorrow we'll talk about inline functions, table weld functions again. I just want to cover more details about that. And then after that, we'll do a short question on 2, 3 questions on whatever we have learned about views and functions. So I'll meet you guys tomorrow and we'll go with that.